Exercise 4C, question 3. Two cars A and B travel towards a junction O on roads which are at right angles to one another. A is traveling east, B is traveling south, so slightly different diagram this time. So B is traveling south. So we have B, and A is traveling east. So we have the velocity of A is 21 in the I direction, and the velocity of B is going to be minus J this time, and it's traveling at 20 meters per second. So the velocity of B is minus 20 in the J direction. So at a certain instance, A is 250 from O, 250, and B is 100, so it's 100 along here. So the velocity of A relative to B, part 1, velocity of A relative to B is the velocity of A minus the velocity of B, which is equal to 21I minus 20J, so in this case plus 20J. The shortest distance, okay, so we need to look in the previous questions, they were telling you, calculate how long it takes B to get there or A to get there. So let's have a look here. B is only 100 away, it's traveling at 20, so B is going to get there in 5 seconds. And how far does A travel in that time? 21 meters per second by 5 is equal to 105 meters. It was 250 away, so now it's going to be 145 meters away. So we draw our diagram here. We have positive relative velocity. So we have A, we have B. They're 145 apart. We have positive, so going this way, so the shortest distance along here. My angle, we're starting at A, velocity of A relative to B, so I probably shouldn't use A as the angle, I'll use theta as the angle because we're dealing with A here. So the tan of theta is equal to 20 over 21. That's not a very good attempt at a triangle. So theta O over A. So the square root of 21 squared plus 20 squared is 29. So the sine of theta is equal to 20 over 29. So the shortest distance is going to be, we see here, well, sine of theta, let's do it the long way. Sine of theta, my right angle is here, is equal to opposite over hypotenuse. So 145 by the sine of theta, which is 20 over 29, and 29 divides into 145 5 times by 20. Shortest distance is 100 meters. In part 3, we're asked the time at which it occurs, which we saw in the example, the time at which it occurs, so we need to find x here. So x is going to be equal to the square root of the hypotenuse minus the other one, so 145 squared minus 100 squared. So x is going to give me, calculator use, 105 meters. And the relative speed, so this is my relative distance, the relative speed is the magnitude of the velocity of A relative B, which we've already worked out to be the hypotenuse, which is 29. So we have 105 divided by 29. 429 is going to be a little bit too much, so it's going to be 3 point. Let's do this one, 3.62 seconds, the time at which this occurs.